So the auto transformer, as here we have seen, the auto transformer is a transformer with only one winding wound on a laminated core. See, the basic difference between the conventional transformer and this auto transformer is that this auto transformer contains only one winding. Conventional transformer will contain two windings. One is at the primary side, another is at the secondary side. So this is the difference, right? But auto transformer is having only one winding. It is similar in a two winding transformer, but differ in a way. The primary and secondary winding are interrelated. Here, primary and secondary windings both are interrelated. So the part of that winding is common to primary and the secondary. So that's why it is having only one winding, right? Which is common for both the primary and the secondary sides. Again, someone is waiting there. There is a disturbance. Joins either you join on the time or join through KBT COE ID. If you join through private ID, I need to allow you to enter. Sanika. So here we have, this is the construction for the auto transformer. So what we have, this is the ring shape core. This is similar to the two winding transformer, only the shape is in circular shape, right? Over the circular shaped core, there is a winding wounded. And this complete winding, which is a part of two fixed terminal, which we can say the primary, where we are giving the supply, right? So this whole winding is connected to the supply, right? Now at the middle, here you can see there is a sliding contact, which is continuously sliding over this winding. See, either this clockwise direction or anti-clockwise. It may be this is the 0 point, and it may be it is a high voltage point. So when we vary this rotary movable terminal, then we can get the increased voltage. So this is the output at one point, and this is the second point. So this is output side, and this is input side, right? So input you are giving to the complete winding, and at the output there is one rotary contacts, and this is nothing but the neutral point, which is common to primary and secondary. Now, according to this arrangement, what we are getting variable voltage at the output. We are getting variable voltage at the output. Potentiometer. Circular shape potentiometers are available. It is having a resistance. So when we give the voltage to the input and take the output, the same voltage, and if we change that potentiometer, we'll just rotate that. Then if the resistance increases, then the output voltage is dropping. And when the resistance decreases, output voltage is increasing. So similarly that, this is called the auto transformer, where the input voltage is fixed and output voltage is variable, right? Here in circuit representation, we can also see these are the, suppose say this is the A and B, these 2 points are there. So in between A and B, there is a complete winding, which is connected to the source. And the part of winding, say this is the movable point C, which is rotating over this coil, right? And the part of that CB, we are getting output. And when we slide this, we'll get the increased voltage. When we decrease this, we'll get the decreased voltage. So this is the variable terminal by which we can get any desired voltage by this auto transformer. This is also called variac, as it gives variable voltage at the output. This type of the pictorial view, the complete model that you might have seen, or if not, then when you come to college, then you can just have this in our electrical machine lab. So this is what input, these are the input point where the plug socket is given. Directly we can connect to the input. Then at the output, this is the neutral point, black one, and this red one, which is a phase point. So we get the output from these two terminals. And now here we can have, this is the rotary movable contact. So by rotating this, see, this is the 0 point, and by rotating this towards the clockwise, then we'll get the increased voltage. And at the end, if it is a single phase, then their rating will be 270. If it is a 3-phase, it will be 470. Standard ratings are there. So this is called the auto transformer. The operating principle is same as that of 2-winding transformer. So it acts as a voltage regulator. If you know, voltage regulator will just regulate the voltage. Whatever the voltage is required, we can set by using the regulator, voltage regulator. So this is like a voltage regulator. Then similarly, that we have seen for 2-winding transformer, step down and step up transformers are also available for auto transformer. So let us see first step down auto transformer. Now, by looking at the conventional transformer, we know that the primary winding is more than the secondary winding. Then obviously we get primary voltage greater than the secondary voltage. Then this type of transformer is known as step down transformer. Same principle applies to auto transformer also. Now look at that how. So consider this auto transformer where the complete winding is AB, which is connected to the source voltage V1, right? Having number of turns N1, right? Then the part of the winding AB, which is CB. See, C is a point where rotary contact is touching, right? And B is the point which is a common neutral point, which is common to this primary as well as secondary. That is the part of the winding. It is common. Here, the rotary contact point C, which is touching around the middle of this coil AB. Now, from C to B, the number of turns will be N2, and where we are connecting the load. So this becomes the secondary winding. Again, I am telling you, there is only one winding in the auto transformer. Now let us consider the circuit diagram for auto transformer. For looking step down, here the A and B, this is the complete winding of the transformer. This complete winding A and B, which is connected to the supply V1, and this complete winding is having N1 number of turns, right? And we know for the secondary, there is a rotary contact. Now this rotary contact is at the position C, and then from point C to B, there is a winding, there is a number of turns N2, and where we have connected the load. So this becomes the secondary winding. So this side is the secondary and this side is the primary. Now we have the equations to calculate the secondary voltage. This is nothing but the transformation ratio K is equal to V2 by V1 is equal to N2 by N1, right? So that's why we have V2 by V1 is equal to N2 by N1, and therefore V2 is equal to N2 by N1 multiplied by V1. So this is how we can get the secondary terminal voltage when we know the primary voltage and number of turns. We can easily get the secondary voltage. Now, by looking at this observation, what we can have, the secondary number of turns which are less than the primary number of turns. That means this is a step down auto transformer. Now, what is the possibility here? See, this C point will be at this. This is the zero voltage. Whenever the C point is exactly at the B, then no voltage will be at the secondary. Whenever the C point at A, then maximum voltage will be at the secondary. And as in auto transformer, there is a self induction. because there is only one coil and there is a self-induced EMF in the same coil. The arrangement is like that. The output voltage will be increasing. Even if we give 230 volt, it will give 270 volt. The standard rating for single phase auto transformer is input voltage is 230 volt and output voltage we are getting 270. This is due to self-induction. Right? So for this transformer, we can get the call it as a step down transformer. Maximum voltage it will be at the input voltage. So A to B, the maximum winding N1 is equal to N2. Whenever this C point is at A, so N1 is equal to N2. So this is the maximum voltage condition. Therefore, again here it is written the transformation ratio again K is equal to V2 by V1, N2 by N1, and I1 by